Hey, welcome back everyone. In this video, we're going to be looking at a very cool and very useful concept in SQL called indexing. So up until now, we haven't been too focused on the speed or efficiency of the queries we've been writing. And that's because we've been more focused on the ins and outs, learning all the keywords there are to learn in SQL. But pretty soon, you're going to be all SQL masters, and writing correct queries is going to be second nature. The hard part, in my experience, is writing efficient queries, especially if you're dealing with big data in SQL. How do you make sure your query is not taking too long to run? In the spirit of learning how to do that, I've created a student dataset not with 5 or 10 students, but with 100,000 students. So the first 10 I've output here. We have some random names, we have some random GPAs, some majors, and some years. To motivate this whole discussion, let's say something we expect to do really often is this statement, which is select everything from my data, where the name of the student is equal to some randomly chosen name. Now think about how SQL is going to execute this using just the 4 columns that are in our data. It's going to have to go through each of the 100,000 students, check if the name matches the name we're looking for, and if it does, it's going to add that to the information it's going to return. And since we didn't make any assumptions here on name being unique, it's going to still have to check all of the 100,000 records no matter what. That can be very slow. Let's see how long that takes on average. So I have this time it function in Jupyter Notebook, and it basically just runs this cell a bunch of times and tells me how long it takes on average. It did 10 loops, and it took about 12.3 milliseconds per execution of this statement. That could be prohibitively slow if I'm doing this very often. Let's see if we can make it faster using an index. I want to explain what an index is. I think the best way I've heard to explain it is the textbook example. So what I just described to you, basically looking for the name of a student by going through all 100,000 records, is equivalent to if a textbook did not have a table of contents, and I asked you to look up some piece of information, you'd have to basically read through the entire textbook page by page until you found that piece of information. Now, if you did have a table of contents, which most textbooks do, you could instead just quickly check the table of contents for the piece of information you want, and then go directly to that place in the textbook. That's analogous to how an index is different from just a brute force scan of the table, which is what we just did. So here's how you create an index in SQL. Pretty simple. Use the create index keyword. Give your index a name that makes sense. So in this case, we're putting an index on the name of the student. So it's going to be called idx_name. You say which table you want to create the index on. And in these parentheses goes the column or columns that you want to create the index on. To keep things simple for now, we're just going to create an index on one column, the name of the student. So let me execute that. And I'm going to execute this statement again, which prints out the first 10 students, just to show you that there's no physical change for the user. You never really see an index. It's happening behind the scenes. So let me run this again. So we're going to run this statement a bunch of times and see how long it takes now that we have an index on the name of the student. So we see it ran 10,000 times, and each execution of this statement took 182 not milliseconds, but microseconds. So let's see how much faster that is. Before it took, where'd it go? 12.3 milliseconds. So we have 12,300. So 1 millisecond is 1,000 microseconds. So it took 12,300 microseconds before, and now it took 182 microseconds. So we got a speed up of almost 70 times. So we can see in this case, indices really sped up our query. Now, some of you are a little suspicious, right? We don't ever get anything for free in computer science. We have to kind of incur a cost somewhere. So where's the cost in this case? It's good that you're thinking like that. The thing that we got was having lookups on the table, so select statements, which involve the name of the student, become really fast. What became slower is updates, insertions, and deletes on the table. Because although the index is not visible to you as the user, behind the scenes there is this index structure imposed on the table. So anytime you update or insert or delete any row from the table, it has to update that index structure accordingly, which can take longer than if there was no index on the table at all. So that's the cost you're incurring. But if you expect to do a lot more selects than you do these updates, insertions, or deletes, then this can be a great tool to use. Now, I do want to give you more examples of indices. So this was a single column index. Let's look at a multi-column index. So let's say the statement we're doing now is select everything from students where the major is some randomly chosen major and the year is some randomly chosen year. Before we see how long it takes, I want to show you the magical function here called explain query plan. This is really cool, and you can use this keyword, not just on index related stuff, but on any statement you're planning to run in SQL. Let me show you the result of this. So if I run this, it tells me how it plans to execute this query. Since I don't have an index on major or year right now, it's simply going to do a full scan of the students table to get me the information I want. Now, the next thing we're going to do is we're going to see how long this query takes. I'm going to get rid of this explain, and let's see how long this guy takes without any index. We see it takes about 40 milliseconds to execute that statement. Now what I'm going to do is create an index. So I'm going to do create index called IDX major year on the students table. And now it's going to be on two columns, the major of the student and the year of the student. So let me execute this guy. We've just created that index. And now the next thing I'm going to do is again explain the query plan. And now we should see it's not doing a brute force scan. It should do something more intelligent. So let me run this guy. And we see that instead it's going to do search table students using this index IDX major year. So this is basically proof to you that the database is going to be using your index in order to execute the query, which basically reinforces to you that the index was useful for this query. Next thing I'll do is see how long this guy takes to run. So let me get rid of this explain query plan statement, execute that guy again. And we see that it took 155 microseconds in order to run this statement on average. Let's see what kind of speed up that is. So before it was 39 milliseconds, so that's 39,000 microseconds. Divide that by 155 microseconds with the index, and it was about a 250 times speed up. So in this case, also indexing was very, very, very useful for us in getting this query to be sped up. I just want to tie up some loose ends and show you a couple of more high-level things on indices. You can use this statement called pragma index list and put the name of your table in order to get a full list of all indices that are on your table. So we just created two in this video, right? We created first the IDX name index, and then we created the IDX major year. So this just gives you a list of all the indices, because if you have a bunch of indices on your table, you might lose track. Another pragma command, you can do pragma index info and put the name of a particular index to get information on which columns are involved in this index. So I said, give me information on IDX major year. And it says, oh, IDX major year is an index on major and year. And it tells you CID, which is the column ID, basically, which column position it is. So this can help you get information on your indices if you've been creating a lot of them. And the very last thing I want to show you is how do you get rid of indices if you no longer want them? Pretty simple. Drop index, the name of your index. So the last thing we'll do is get rid of both of our indices. So I hope this was a good introduction to you on how indices in certain situations can really, really, really speed up your code. But I also want you to keep in the back of your mind what costs you're paying for it. Although we didn't show in this video, these indices that we created did speed up our selects, but they're going to slow down our updates, inserts, and our deletes, because all of these things have to do some stuff on the index to make sure all the bookkeeping work behind the scenes is kept track of, which is going to take a little bit longer, take a little bit of overhead costs, and that may not be worth it in certain situations. So this was all about indices in SQL, and until next time.